In this lab, we're going to be talking about how to use pulse width modulation, or PWM, to control the brightness of an LED. We'll start out with a little bit of a background on PWM. In a previous lab, we talked about how we can light up an LED using an Arduino, specifically an Arduino Nano, using the digital pins. In this case, we're going to talk about how to use pulse width modulation, which is a technique that you can use to control the power supply to a variety of different electrical devices. In this case, PWM can give the appearance of dimming and brightening an LED light, where before we were only able to supply a constant 5 volts or 3.3 volts from the Arduino Nano. And in our case, we'll be able to simulate different brightness levels in between 0 volts and 5 volts, and I'll show you how that's done. So, the basis of PWM lies with different duty cycles. And what that means is that the circuit is not giving a constant. In our case, we're using the Arduino Nano, so it can supply a 5 volt line. And let's say the circuit is off, so it's not supplying any voltage. Let's say 5 volts is up here and 0 volts is up here. This is equivalent to a 0% duty cycle. And that means that the circuit is basically on 0% of the time. In contrast to that, we can have a 100% duty cycle, which means we're basically getting a constant 5 volt supply. Now, in between that, we can have duty cycles, so that's 100%. We can have duty cycles in between 0% and 100%, let's say 50%. And that would look something like this. We may start off at 5 volts and then go down to 0, stay at 0, go back up to 5, stay at 5, go back down to 0, and so on and so forth. And as you can see, we're spending about 50% of the time at 5 volts, and we're spending about 50% of the time at 0 volts. And hence, we are at a 50% duty cycle. And so in real life, what that means is if we were running an LED at this duty cycle, we would have the appearance of a light level somewhere in between what we would see at 5 volts and at 0 volts. So if we actually put a multimeter up to this, it would say somewhere around 2.5 volts. It'd be taking the average of 5 and 0. And so in real life, we can have basically anywhere between 0 and 100% duty cycle, and we'll be exploring that during this lab. Alright guys, so we are going to start building our circuit. Here are our basic components that we're going to use. Here we just have a simple breadboard. We have our Arduino Nano, and we're going to be using, in this section, we're only going to use 2 of these LEDs and 2 of these 1K resistors. Further on in the lab, we'll use a few more, but we're going to start with these. So our first step is we're going to connect the Arduino Nano to the breadboard and make sure the pins on either side of the Arduino are on different parts of the breadboard so you don't run into any issues there. Next step, let's ground. We're going to connect one of these rails to the ground on the Arduino. We're going to have multiple components that connect to ground, so having a grounded rail is going to make our lives easier. Alright, now we're going to connect 2 wires to 2 digital pins on the Arduino. And since this is a PWM lab, we have to make sure that we are connecting to digital pins that support PWM signals. And on the Nano specifically, we can choose from pins D3, D5, D6, D9, or D11. For now, we're just going to go with D5 and D6, just to make things easy. And we can connect these somewhere over here. This is where our LEDs are going to go. Alright, next step is to insert our LEDs. And if you notice on these, there is a longer side and a shorter side to each LED. And that's because they have very specific terminals that you have to attach them in a very specific way. So in our case, make sure that the longer lead on the LED is closest to the digital pin on the Arduino. So in our case, our PWM signal is going to be coming from the digital pin, coming right over here, and we want the longer end of the LED right up against that. So we're going to plug that in right there, and then we'll get our second LED. All right. And then coming off the LED, we're going to be putting a 1K ohm resistor, and that's going to be connected directly to ground, or that ground rail that we set up earlier. Alright, so that's the basic circuit setup, where we will go over the code that we need to make this thing work, and we'll come back and show you it in action. Alright guys, so we're going to go over the code necessary to make our circuit work with the two LEDs that we have. So to start out, we're just going to initialize two digital pins down the Arduino. We're going to call digital pin number 5 LED pin 1 and digital pin number 6 LED pin 2, and those are both initialized as integers. Now we're actually not going to do anything in setup because we don't need to, and as you can see, our loop is very simple. All we're going to do is use the analog write function to write to each digital pin that we initialized above, and this function has a range of 0 to 255, so basically 0 corresponds to a duty cycle of 0% and 255 corresponds to a duty cycle of 100%. So we're going to set LED pin 2 to basically a 100% duty cycle, and LED pin 1 to a very small duty cycle, which will be equal to 5 divided by 255. So let's see how this works on our circuit. Alright guys, so we're back with our first circuit, and we can now test our code and see if it works. We're going to plug in the Arduino to our laptop and run our script. And if you've implemented your code correctly, this is what you should see. So as you can see, this LED right here is at full brightness. I think I set it to 100% duty cycle. And then the other one, you can see, is definitely not as bright. And I set that to 5 out of 255, so it's at a very low duty cycle, and that's because it's kind of hard for the human eye to see, let's say, a 50% duty cycle, or the difference between a 50% duty cycle and 100%, so I set it very low for that purpose. So in the next section, we're going to add a few more LEDs and set some timing parameters, and we'll see how that changes things.